Cool. So my name is Yatish. As Michael said, my Twitter handle is Yatish27. That's also my GitHub handle. So I tweet a lot about Ruby, Rails, these days Go, Sketch. So if you're interested in these topics, feel free to follow me. I live in SF, so it was a pretty long flight. I actually flew via Amsterdam, so it took me 21 hours. This is my first time in Africa, so thanks for the organizers for inviting me. Special thanks to Michael for his help. Thank you so much. I really love collecting stickers. So I have enough stickers that I now need to buy a new laptop. Now, if anybody is interested in stickers, I have some. I can give it to you. I also love mechanical keyboards. So if you want to talk about Cherry MX Red, Cherry MX Blue, I'm available. Cool. So I work for this awesome company called as Coupa Software. I'm a senior software engineer over there. Coupa is into spend management system. So basically anything that a company spends goes through Coupa. That is expense report, requisition, invoices, contracts, supplier management. Our CEO describes it very well. The way Salesforce is for sales, Coupa is for spend. The core Coupa app is a Rails, Ruby on Rails monolith, and we've been talking about monolith since morning. And it's a pretty large monolith. I'm pretty sure it's at least one of the largest Rails app out there. So let's go through some stats to give you an idea, and then we can talk about this. So we have more than 750 customers. These are enterprise customers. So to go live, it sometimes takes even more than a year. Our clientele includes companies like Uber, Salesforce, P&G, Unilever, Staples, Capital One, Barclays, and like many more. We support more than 20 languages in 100 countries. We also have we support 150 currencies. Recently, Akira from Cookpad gave a talk about Rails, the biggest Rails app, the recipe for the biggest Rails app, and he ran few stats. So I thought I'll go through similar stats. We have like more than 1 million line of codes, 1,200 models, and 450 controllers. More than 7,000 routes. So think about the route file. It actually has more than 7,000 endpoints. In total, we depend on like 512 gems. That's total bundled. We have more than 25,000 RSpec examples. These are just unit tests. There are more integration tests on top of that. Because our product is very configurable, we have to have large number of integration tests as well. 7,000 tables. This is the core app that we are talking about. We have more than 7,000 tables. And this app is developed by 200 developers in 5 different time zones. So single monolith, but 200 developers in different countries, 5 time zones. We have around, so last I checked, we have around 1,500 commits that happen every month by these developers. And we've been using Rails way before, like since the start. So if I just did a git log reverse, and you could see this is the first commit, and this is actually even before we were using SVN. So this is the first commit, and it shows 12 years. So there's more than 12 years of active development on this app happening. Okay, so when I look back and to see the journey of this app, a simple prototype has now turned into a complex, proper, gigantic monolith. And how we've grown and how should we move forward, let's look at that. So monolith, in terms of architecture, monolith is at one end of the spectrum. So a monolith is something where everything is inside a single app. It has a single database. So everything is simple to find. Like if you want to find a contract or an expense report, you just do expense report.find or a contract.find. The deployment is simple. But this makes it difficult to scale not just the app, but also the organization. So if a new dev comes in, the person needs to know everything about the app. There's no functional boundaries. On the other end of the spectrum, you have microservices. Each functional component is a different app. It has its own deployment, database. It's easy to grow the organization as the devs need to know only about that specific app or just specific service. Amazon actually does a really great job. Every team in Amazon is basically a microservice. But when it comes to microservices, deployments can be difficult. Everything is an actual HTTP request. Things about latency, throughput come into consideration. And again, there's a lot of debate about microservices. Should we start with microservices? I don't want to get into that. But basically, that's the other. You get some positives with microservices, some positives with Monolith. So how can we be in a middle space where you can get the best of both worlds? We want the simplicity of Monolith, but the functional separation and encapsulation of microservices. What we are calling it is like service-based Monolith. So how do we come to know that we need to move to the next level? How do we move from monolith to a service-based monolith? With time, as the complexity of our app grows, there are a lot of code smells that creep in. And let's kind of go through them. Spaghetti controllers. So this is a typical Rails action. The code is pretty, this is what we want. I mean, a single instance variable, this is beautiful code. But this is not what actually happens. In reality, this is what happens. You have complex controller actions, bunch of nested if else statements, multiple instance variables, bunch of before filters, you're massaging your params. There's a lot of things going on in a single controller action. And like these are real world. When your application grows this big, you will see such actions. Next is callback hell. Active record gives you a lot of hooks and callbacks that you can talk to. But as time grows, your business logic is distributed between these web of before saves, after creates, and a bunch of them. This is an example of a callback hell in ASM state, where, as you can see, there's logic distributed in the on enter, after enter, and obviously there'll be events and stuff. So as you can see, there's logic in the enter section, there's some logic in the after enter, and this is actual business logic. This makes it really difficult to understand and read the code. Last one, if you've been in the Rails community, this is what you must have heard, thin controllers and fat models. This works for simple and intermediate apps, but what if your models become really, really heavy? What if they include responsibilities of decorators, business logic, class methods, which are basically helpers and stuff like that? I don't know about you guys, but this is my reaction when I look at that code. I just wanted to use this meme, so I had to fit in somewhere in this slide. So yeah. And I think this is the right time to refactor and move from a monolith to a service-based monolith using service objects. What are service objects? Service object is nothing but a simple class which encapsulates a single unit of business logic. So if you look at this, they're simple, plain old Ruby objects. You have an initializer and just a single public method. Each class represents a unit or a process or an action. I like Martin Fowler's quote about service objects. Defines an application boundary with a layer of services that establishes the set of available operations and coordinates the application's response in each operation. When Martin, so this was another post that he made on the Ruby mailing list where he was reviewing Eric's domain-driven design. Uses the service object to refer the object that represent process. This is a very important sentence. Service objects to refer the objects that represent processes as opposed to other terms like entities and values. Service objects are often useful to factor out behavior that would otherwise bloat entities. It's also useful to step to patterns like strategy and command. So basically when you move to service objects, you start a new design pattern which is on the lines of strategy, command, or maybe a bit into the direction of publisher, subscriber. Talking about that, what exactly would how would you define or see a service object? For me, it's like a black box to the outside world. So in the given example, let's say if I want to submit a contract for approval, I don't need to know the entire logic. I just call the service object, pass in the arguments, and damn, I get the results back. I don't need to know what happens. I don't need to know the business logic behind it. It may happen some other team owns contracts, but these are the endpoints, or these are the service objects, interfaces that are available. I just need to know what they do. In the real world example, metaphor would be when you go to a Subway sandwich, you need to know everything about the Subway sandwich. You need to know the bread, you need to know the toppings, the meat, and everything. But if you go to Starbucks, you just say, hey, I need this coffee. You don't need to know about the beans, the ratio of the milk, and sugar, and everything. You just pay them, and you get coffee. So I think I like this metaphor of Subway versus Starbucks to understand what service objects are. So there are many ways, if you check on the internet, there are many ways to structure service objects or define a service object. This is how we are doing it at Coupa. So, yeah. So this is an example of when you're creating an approval chain, this is the service object we use. So initially we include the vertex gem, which gives a simple class more power. And you also include a base class just to include all common functionality. There's also other gems like dry RB that you can use instead of this. There is, I think, application resource, which has come out where you can use the same power, similar to vertex. What vertex does is it gives you an ability to define types to your incoming arguments. So in the initialize, I don't need to even define and initialize and do the validations and stuff. So here, as you can see, the document key needs to be of the type approvable, which is a class. The template needs to be of type string. With proxy is basically optional. If I don't pass, it defaults to false, a Boolean type. And rules is a custom array, which I've defined maybe in the base class or somewhere. So as you can see, you've taken away the main logic of validations, defaulting outside your main call method. Then you can define custom exceptions if you have any. And finally, this is your main single public method. People also call it, like GitLab calls, if you look through GitLab's code, they call it execute. Some of them call it perform. As you can see, the main logic is broken down into smaller private methods. This makes the main call method quite readable. This is the base mixin, the second line that you see, service base, where you're wrapping the call method, adding some syntactic sugar so that you don't have to call new. So you just say approval chain create dot call. Inside it, it's going to create a new instance and call the instance method. So adding some syntactic sugar. You also have, if you want to wrap the call method into a transaction, you can also do that. So there's an option to that. So all these utilities for your service objects, we are defining it in the base class. This is a file structure. As you can see, we put all our services in the main app folder itself. And as you can see, they're namespaced according to functional domains, suppliers, contract, expense report, invoices, sign providers. And this not only helps in code organization, but even when you're growing the team, it's easy. So now my team is just going to own like 2 to 3 folders. Another contracts team would have their own folder. That really helps when you're growing a monolith, still having this functional encapsulation. The naming convention that we use is something of this sort, where you have the service, which is the prefix, then the noun, which is the entity or the resource name, and finally the verb, which defines the process or the action. So if you look at this example, we have service, Maybe the entity name is a contract or signature provider. And finally, the verb, which defines the action or the event. So you could have nested resource names as well. So you could have service, signature provider, colon, contract, colon, request token or something like that. So when you introduce service objects, you need a good heuristic to understand, hey, when is it right to use, when should I not use it? And I really like Brian's blog from Code Climate, where he explains very well, like if you look at a pattern, and see, hey, I think I need service objects here. So let's say if the action is complex, you need a service object. If the action reaches multiple models, if the action interacts with an external service, like calling an API or something, if the action is not a core concern of the underlying model, if it doesn't belong to any kind of persistence logic, it shouldn't belong to the model. And if there are multiple ways of performing the action, like authenticating with an access token or password. So if you see these patterns, you know you need to go in the direction of service objects. Finally, I'm pretty sure people have heard about the Rails doctrine or the Go proverbs, the Zen of Python. So I thought, let me come up with a list which makes good service objects. So the Zen of service objects. Like the UNIX philosophy, do one thing and do it well. Like instead of creating one big service objects, it's better if you have smaller service objects and then stitch them together. Have a wrapper service objects which uses them individually. Be stateless. Do not set any global state inside the service object. Something like user.currentUser, setting any global variables. Do not do that inside your service object. Return them as values and let the consumer of the service object do that. Also inject your dependencies. Write your service objects in such a way that you can even use it in your Rails console. It's not dependent on your controller state. So if the service object requires a current user, you pass it explicitly. Be immutable. Do not mutate the incoming arguments. Always return a new object. Clear is better than clever. This is from the list of Go proverbs, and I think that really suits for service objects as well. Naming variables has been one of the most difficult problem in CS. So while you're naming your service object, remember that's the interface that other devs, other teams are going to use. So make sure you name it clearly. It signifies what it's doing. Be very explicit when you're naming your service object so that it's easy to understand. Fail for validations, but handle exceptions. So this is the main one, where, as you can see, as you saw in the main structure, we take care of all the validations, the defaulting logic. But if any kind of arguments are incorrect, you actually explicitly fail. You raise an exception. But if the business logic has an error or something of that sort, you need to handle those gracefully. Return them as errors, return false, and maybe return them as errors, and let the consumer of the service object use it. Finally, the next steps. So we've moved from service objects, and now we're in the direction of moving each functionality into Rails engines. We've successfully moved 3 of our verticals, contracts, sourcing, and inventory, into engines, and now we have other functional components that we are moving it into engines. It'll still be a part of a monolith, but functionally it's separate. And finally, then we would, if possible and if needed, we'll move it into separate apps. That's it. Any questions? Any questions? Yeah.
Since using inverters, have you seen a dramatic decrease in code complexity and line scope?
It has, because you don't have to, like the normal validations, the data type, it kind of adds a strong typing to your call method, to your service object. That's really helped us. So if anyone who's using the service object passes in wrong objects, or because Ruby is dynamic, right? If it responds to that method, it's going to allow that. But we don't want that. We want to be strict to the arguments that we are passing in. And we want to take care of that outside the call, outside the initialize method. So that's really helped us. We also use dry. I think Virtus, this development has been stopped. So it works for us, but if you want to move, you can use dry RB. That's also a good option. Thanks.
So, and ask is, your organization using feature-based application structure and at the same time the roles-based?
What do you mean?
For instance, in Rails most of the times recommends use of the base.
Right,
That you use
right. You would still have the models and the controllers folder. This is an extra folder which is which is removing logic which is inside models and having functional separation. So it's not, we are still using MVC, but the responsibility of models is just the persistence layer. It doesn't have any business logic. So I think PJ mentioned about a Trailblazer, and if you read about operations, it's on the same lines.
Okay, my question is with regard to how do you test the service architecture, considering that for such as yours, with up to 1,000 models,
Right.
you have like everything scattered all over. How do you actually ensure that you test it in terms of how will you maybe, yeah, how do you ensure testing whereby it covers the seamless operation of the application?
Right.
And in addition to that, why don't you use, for example, you take a modular structure whereby you just extract some of these services as gems? Because I think I saw that
Right.
that the service architecture in Rails is actually going for.
Right. So to answer your first question, how do we test it? Because we've separated out functionality and business logic into explicit classes, it actually becomes much easier to test it, because each service object has just one responsibility and you're passing on the dependencies. So you can actually have unit tests to check what the service object is doing. So in terms of testing, this architecture actually helps you. Second, in terms of removing and moving it into gems, I think that's the direction we're going. As I said, we've moved it into 3 engines, which is technically gems. So we're going in that direction, but considering it's a 12-year-old app, you can't just take and move it into engine. It's a pretty slow process. Good. Yep.
Yeah, thank you for the presentation. So on the same design patterns, we have interactors. So we have a gem called gem interactor. It does the same thing, almost like service objects. So I don't know if you have interacted with them.
Which gem?
Interactor.
I'm not sure I'm aware about that.
Okay. Yeah, it's kind of like service objects. It does the same thing. One file does one thing.
Right.
It's written the same in a similar way as service objects are written.
Right.
Okay, it's fine. I wanted to know the difference.
I'm not aware about that one, but I have looked into application resource, which is a new gem, and dry RB to use the similar patterns.
Okay, thank you.
Hey.
We tried to do the same thing, break down a monolith,
Right.
but we started with the engines.
Right.
I'm just curious as to your thought pattern. Why not functionally break it down in engines and leave those engines have your services?
Right.
As opposed to creating all these services. It sounds like, correct me if I'm wrong, your engines, breaking the engines part is your next step.
It's still in the process, but a lot of our code doesn't require to go to that level of abstraction. It's not, like for example, the entire contracts app is functionally encapsulated in such a way that it can be moved to an engine, but a lot of our code doesn't need to go to that level. So for that functional breakage, we've still stuck to service objects. So if we find that, hey, this is a big enough app that can be moved into an engine, that's what we've done for contracts, sourcing, and inventory. And I think if we find, hey, this is a big chunk, we can move it, we'll go in that direction. So.